So kudos to all of you who continue to stay all the way to the end. I appreciate that. We've got two great panels. We've got high energy for the Energy Summit going all the way to the end here. So the last two panels, we're going to queue up this one, then I'm going to moderate the last panel. We'll talk about jobs. But this panel is about innovation and future opportunities. So if that panel come forward, it'll be Mark Peterson, Curt Pohl, Carl Borgquist, Crystal Cunniff, and Shannon Angielski. This will be talking about how to reduce our dependence on foreign energy while sustaining a resource for generations to come. You know, Montana is unique that we feed the United States, we feed the world, we fuel the United States, and we have an opportunity to fuel the world. And a nation that can feed itself and fuel itself, and more importantly, a nation that can feed the world and fuel the world is economically going to lead, and from a national security viewpoint is going to be secure. This next panel is entitled Innovation and Future Opportunities. We're going to hear about innovative practices in Montana's renewable energy and electricity, as well as offshore drilling, how Montana Tech contributes world-class engineers to energy industries. So I want to welcome our moderator, Mark Peterson, professional engineer and chief operating officer at GTUIT, and our panelists, Curt Pohl, vice president distribution, NorthWestern Energy, Carl Borgquist, CEO of Absaroka Energy, Crystal Cunniff, senior drilling engineer in the Gulf of Mexico from Cobalt International Energy, and Shannon Angielski, executive director of the Coal Utilization Research Council. Please welcome another great panel. Take it away.
Thank you, Senator. Appreciate that. I'm Mark Peterson. I'm the Chief Operating Officer of GTUIT. And before we get to the panelists, I was asked to give a brief history of GTUIT. We're a Montana-based company and an innovative company. And that's why when they asked me to moderate, I had no qualms about doing it because it's something that's near and dear to our heart. So just a brief history on our company. Basically, we know that a lot of you know how well the Bakken development has gone, and it's been amazing to watch the shale oil boom happen. But it has come with some problems, and as engineers in our company, we saw the need to solve the flaring issue. And so I partnered about 5 years ago with two Billings engineers, Jim Hayter and Brian Siebel. And our goal was to solve that problem. And in 2011, we actually started to put together some equipment on a well site, and we use off-the-shelf technology to do that. And in the summer of 2012, we actually got that equipment up and running. And basically what the equipment's function was turns out the gas in the Bakken is a very rich gas. By rich gas, we mean it has a lot of heavier hydrocarbons that can be condensed out and made into a liquid product that can go to a refinery and be further processed for commercialization. So that was what our goal was, and we started to build this equipment with what we called off-the-shelf technology. And through the summer of 2012, we busted a lot of knuckles and learned what to do better. We ended up building our own and designing our own system because we realized that off-the-shelf technology was not prepared for the richness of the gas that's in the Bakken. So we started building units that we designed and built them right here in Billings, Montana. And it's good for the economy here. We certainly have a lot of vendors and suppliers that we're helping out here right in Billings. As of right now, we have about 40 employees and 20 million standard cubic feet of gas processing out in the Bakken operating. Of course, as everybody knows, the oil prices started to slide, so our growth trajectory started to slow down as well. But innovation is what's keeping us going right now, and we're looking at new technologies to offer throughout the world, actually. As some of those examples are, in 2015, we, through a Caterpillar Oil and Gas minority equity investment, we were modifying our equipment to treat fuel to run engines and create power. And this has been a big deal for us because we're getting a lot of interest around the world, frankly, from countries I had to go check on the map where they are, to produce remote power, distributed power. So that's something that's really making our future look fairly bright. The other thing we're doing is bringing in H2S technology on a well site that is about the 10th of the OpEx of a standard well site H2S treatment. And then finally, and not least, we are also somewhat of a gateway technology that allows other methane-based technologies, as I would term them, to be viable on a well site. And we just recently were part of a project that, and we believe we're the first in the world to do this, make LNG from flared gas. So that fuel transportability opens up a whole new world for us. So with that, I'm going to get here with the panelists, and I'm going to ask each one of the panelists to maybe talk a little bit about what they do for their companies and some of the projects that they're working on, just so you have a little bit of background before we get into the real questions. Curt, if you don't mind.
Sure. I'm Curt Pohl, Vice President of Distribution for NorthWestern Energy, and my main function or main responsibility is for the distribution systems. Work very closely with our Vice President of Transmission so that we work together on operating our transmission and distribution delivery systems across our 3 states, both electric and natural gas in Montana, South Dakota, and Nebraska.
I'm Cunniff. I work for Cobalt International Energy, and if you missed our CEO's keynote speech yesterday morning, you probably also missed my Hollywood debut. I work as a drilling engineer, primary focused deepwater Gulf of Mexico. Cobalt works offshore Gulf of Mexico and offshore West Africa. I'm focused Gulf of Mexico. One of the things that makes Cobalt interesting from an exploration and production company is our focus in deep water. We focus on lower tertiary, which is located roughly 35,000 feet deep. So we have drilled 5 of the top 10 deepest wells offshore in the world. So technology and innovation is just a part of the fabric of our company. So.
I'm Carl Borgquist. I run Absaroka Energy, which is based in Bozeman, Montana. We're working on projects mainly across the northern tier, Montana, Wyoming, North Dakota, and those are a couple of larger pump storage projects. You might have heard me talk about one of them yesterday. Some transmission and small geothermal. We're also getting involved in a solar project in Africa, which has been fascinating. So our footprint's starting to grow.
The Coal Utilization Research Council is a Washington, D.C.-based technology policy advocacy organization. We're a membership organization, and we span the gamut from all the industrial supply chain in the coal industry, from the producers and users of coal to the equipment suppliers and technology developers that are innovating in this space, including also research institutions. We also have labor organizations and others that are involved in our advocacy efforts, as well as some of the state organizations. And our mission is really to focus on the research and development needs for advanced coal-based technologies to ensure that we have future coal-based options that are both environmentally compatible and cost-effective with what we see in the future as the need to be low-carbon generating options. So that's the focus of our organization.
Thank you, Shannon. I'm going to start off with a question for everybody, and I think I've seen in the previous panel some 2-part questions, but we're going to up our game here. We're going to start with a 3-part question here. We're going to make it tough. And I'll start with Curt and just let you guys go on down the road here. But so the first part of the question is what is the single biggest opportunity for Montana energy development in your field? Secondly, what is your biggest challenge to overcome in fulfilling that opportunity? And thirdly, how can innovation get you there?
3 parts. Okay. Well, I might answer that a little bit differently. I view NorthWestern as an essential service provider of electric and natural gas. And we do that through our transmission and distribution delivery systems. So I guess, I view us as more of enablers of others to develop energy, as well as our own delivery of our generation and so forth. So I suppose our greatest opportunity is to stay focused on, our constituents, what they need to properly develop energy for the future, and basically stay ahead of investments that are necessary in our infrastructure so that we could adapt to that changing environment. The challenge, probably one of the biggest challenges, is the cost benefits, and making sure that we truly understand the cost benefits, and making sure that we're working together to align those costs and investments that are necessary to develop energy so that it's fair to all stakeholders. From an innovation standpoint, there's already a lot been done. At least in the energy sector, in the electric delivery systems, there's a lot of automated technology that's out there. There's a lot of automation and a lot of technology that we have yet to deploy. And so the opportunity is there, and we can learn from our from other utilities that have already adopted a lot of things, and learn from what works, learn from what doesn't work. Again, I think the innovation's really going to come from a collaborative effort of a lot of different folks, a lot of different ideas, so that there's multiple solutions for energy development.
I think the biggest opportunity in Montana in the petroleum field is obviously untapped resource plays. We all know we share the Bakken with our neighbors to the east, but what else is out there? I found it interesting, Karen's presentation yesterday, she had a couple of fields identified as unproven, right? So considering how much resource has been identified and found and proven and produced in the last 10 years in onshore America, I think that is really where the opportunity in Montana is to efficiently produce those proven barrels and find the ones that are yet to be discovered. So as far as the biggest challenge to overcome in Montana for that, I think is kind of a twofold thing. First, for me, is a certain amount of perception in Montana. We don't have the large legacy oil fields that exist in Wyoming and North Dakota and other parts of the U.S. So this boom of unconventionals that has happened in the last 10 years is kind of, I think, been a new phenomenon for Montanans. I found it interesting, a few years ago, there was some exploration drilling companies that were looking to put some wells on the Rocky Mountain front, outside my hometown of Shoto. So, needless to say, I got to witness a lot of the fear and uncertainty, the little bit of hesitation for the local landowners to welcome that. I obviously fielded a lot of phone calls as far as trying to get education around what does the petroleum industry bring, what are the pros and cons and that kind of thing. So I think overcoming that perception in order to welcome this industry more is going to be critical in order for that development to proceed. The other thing I would say is as far as the economic attractiveness. So barrels in the ground all over the world have a value, and they're different. And you want the barrels in this state to compete with the neighbors. So that's a critical piece, is to make sure that when a company is looking at their budget and deciding where they want to put those dollars, that they put them here, not across a border. Oh, and then I guess is, how are we going to get there? Those are the challenges, but as far as with the unconventionals being a relatively new play as far as the oil industry is concerned, one of the critical areas for innovation going forward, aside from optimization, efficiency, which is just part of the evolving process for operations, recovery is going to be critical. Seeing how these fields respond from a production standpoint, ensuring we get maximum recovery is going to be critical go forward, and it's going to require a lot of innovation.
Okay, I'm having a moment of panic right now because I can't remember the three questions. So bear with me as I fake it. Okay. I think the market and what's happening is creating both opportunity and challenges for us. And it's a kind of a double whammy of things are moving and holes are coming open, other things are closing. And so it's interesting to try to anticipate and fit into all of that and bring these development capital intensive, very complicated and stakeholder driven projects into the marketplace at the right time with the right fit and what people really want. That, again, there's opportunities and challenges in that. And I think what we're trying to do is approach, first of all, we're approaching the pipeline of projects we have in a strategic fashion because we can't develop all of them at the same time. We're trying to pick the ones that seem to fit with the moment that we're in, even though we're doing several of the smaller ones along with this larger Gordon Butte project. But it's a day-to-day challenge to keep the development capital flowing, keep the projects moving, manage the regulatory risk, and then lastly, with this Gordon Butte project that I talked about yesterday, just try to fit into what has become an evolving market in the electrical grid as we evolve and change what generation assets we put into it.
Thank you.
So for the coal industry, I think over the past day and a half or so, I think you've probably heard from a lot of different folks about many of the challenges that this industry is facing. And while I'd like to paint a rosier picture, I do want to say that I think technology is really what the solution will be for the industry that does paint that rosy picture for the future. And so just to maybe summarize, I think a lot of what we heard over the past day and a half is really what some of these challenges are and how we're responding to them from a technology perspective. So you've heard about the regulatory challenges, talking about criteria pollutants and the mercury rules, for example, that are going to be shutting down about 50 gigawatts of our existing coal fleet. And we also heard a lot about the Clean Power Plan and these new source performance standards that are challenging us and requiring more technology innovation in the future. The others are market challenges. As here in Montana, there's a lot of natural gas, and so it's very low-cost gas. And so we are competing with that as well as regulation that's driving generators of electricity to use that gas and replace coal capacity. I think some of the other challenges that we haven't really heard much about are the oncoming or the increase in capacity of renewables and the need for our existing fleet to be able to respond to those renewables and be more intermittent and flexible in their operations in terms of load following. And then the other that we haven't really talked about yet is the fact that maybe not out west, but a good part of our country is seeing the coal fleet reaching an age where we need to start thinking about retiring the baseload fleet. So we're looking at that as more of an opportunity to really, in fact, develop those technologies that could really be step change, transformational technologies in the way that we convert coal to useful energy. And by virtue of those processes, also be able to more cost effectively capture and sequester the CO2 from those facilities. And so some of that innovation is really being driven by those challenges, and also in looking at ways to develop those energy platforms that are smaller, more modular and compact in order to be lower cost, and also to respond to the fact that the load demand today since the recession is much lower than it has been in the future, if not flat. And so with these more modular types of systems, you can more incrementally respond to generation capacity needs, but also more cost effectively have options available to replace retiring capacity, whether from regulation or through the aging of some of the coal plants that we expect to see in the next 10 to 20 years.
Thank you, Shannon. I'm going to direct this next question to Carl. Carl, in your opinion, what will the transmission grid look like 20 years from now, and what steps do we need to take now to get there practically and efficiently?
Well, I think, I keep paying attention to this duck curve that's happening in California, if you've heard that expression. And it's basically, they're installing so much solar generation that they're going to be in an over-generation state. That's going to have some effect on the market, particularly as these utilities join a shared market or a common market. We're seeing a lot of folks wanting to cut ties with the grid. The generation fleet is changing. And so I made this comment yesterday. I think it's still appropriate to answer your question. You know, we used to identify a load, we would build some generation, we tie it together with transmission, and we developed a grid that was relatively linear. This thing, if you take where we're at right now, regardless of the mix of generation, and you just look at it changing and evolving going forward, I think we're going to have to be more nimble about how that gets managed. And I think there's an opportunity to really responsibly, intelligently evolve into that change. We never change anything without some bumps and hiccups and difficulties as we're moving there. But again, every time we've changed the way we produce energy, we tend to have a lot of innovation and growth and entrepreneurial behavior that comes out of that in all sorts of forms rather than just energy. So I think there's a lot of excitement too. And the other thing I wanted to say, which I haven't had a chance to mention in my comments, is I don't want to be afraid of us building big things and making big changes and responding to what's happening into the world. We're Americans, right? I mean, I want to sort of march into that smartly and boldly and strongly.
Thanks, Carl. I appreciate that. Shannon, this one's for you. What are the major impediments to coal-derived power, and how is the coal industry driving innovation to respond to those impediments?
So I want to say that I think I covered that good in the last.
I think you
response.
did. I think you did, but.
But some of the, maybe I could talk a little bit more about some of the technologies that we're kind of evaluating in order to get us there as well.
Well, yeah. What are the ones that are leading economically?
Sure. Well, maybe what I should do is just talk about what we have available to us today from a technology-based perspective. I mean, we have very highly efficient coal plants that we could be building today, some of which we don't have here in this country, but many of which we're building around the world, and that's something that we could be doing here if we had a regulatory environment that enabled us to do that. We also do have all the control technologies that have been developed and deployed here in this country for all the criteria pollutants, where we also have water use and management technologies that can be deployed. Some of them come at a cost, and so it's a question of trying to evaluate economics of applying those to an existing unit. But the next step and really the next challenge, as discussed, is really this greenhouse gas and CO2 emissions challenge with respect to coal use. And there are several technologies that are in the development pipeline that are technologies that could capture CO2 on both an existing plant as well as on a new plant, as well as these new energy conversion platforms that produce a concentrated stream of CO2 as part of their process. The challenge that we're facing today with these technologies is that they're still in the development phase if we're talking about applying them to an electric generating unit. Some of these technologies have been used in industrial processes where you're producing a high-value byproduct, but when you're producing reliable electrons that need to get onto the grid, applying those technologies and integrating it into that kind of a system is not something that we've done, at least in this country, in a way that we have enough operational data to be able to replicate that confidently and more cost-effectively. So the next step really is to not only develop more advanced technologies for capturing CO2 that are use less parasitic power and have lower cost. That's one development effort. But the other is to learn by doing and let's get some of these technologies actually deployed and demonstrated in the real world in a real integrated process while we're putting electrons onto the grid, so that way we can confidently go forward as an industry and say that this technology is going to be an effective technology.
Thank you, Shannon. Curt, you had mentioned earlier that you're kind of staying the course, paying attention to your customers and making investments in your distribution system. Can you describe what types of investments NorthWestern's doing?
Sure. Carl talked a little bit about this and, what's kind of required, transmission systems, distribution systems. I talked a little bit yesterday when we were talking about infrastructure of all the investments that we've made over the past several years, just to take care of, fundamental core services and make sure that our system's reliable going forward into the future. One of the things that I think I pride our company in, and I think we're ahead of our peers, is we have a pretty strong asset management model, and our engineers that are part of the asset management process have developed pretty strong modeling capabilities on predictive analysis, on tree trimming, on reliability. In other words, if we invest so much in tree trimming, what's that going to produce for us? If we invest so much on replacement of underground infrastructure, overhead infrastructure, and so forth. But the environment that we're talking about in the future with a lot of distributed generation, I talked a lot about distribution management systems. And that's probably the challenge that we have. Systems today, Carl mentioned this, they're traditionally designed to flow one direction. So you have generation, flows through transmission, flows through distribution. So if you can imagine a circuit that say has 1 to 3 megawatts of load on that circuit, but you have distributed generation on that circuit that exceeds that load at any given time. We have to figure out what to do with that generation. It might seem simple that it just simply flows upward into the transmission system, but there's a lot of things that go into it from a voltage support standpoint, frequency support, and so forth. So we have to make sure that as we accommodate that, obviously those distribution systems remain stable and reliable. The other thing is that in most cases, the distributed resources that we're talking about are intermittent. So, at some point, there has to be balancing of those resources, whether it be through some form of storage or some form of thermal backup. And that could happen at the transmission level, it could happen at the distribution level. So we're heavily focused on investing in the automation that we have to do in order to develop that. So, some of the things we've done in just the past couple of years, we've implemented outage management systems. We have mobile workforce capability through, mobile dispatch and so forth. But now we're really focused on the communication network that's going to be required to invest and be able to connect automated resources that talk to each other so that these systems can be automated. So in a nutshell, that's what I was talking about.
All right, thank you, Curt. Crystal, you're a native Montanan from Shodo, and you went to Montana Tech.
Correct.
And you're obviously on the cutting edge of technology if you're drilling 35,000-foot wells. So my question to you is, how can some of that technology that you're obviously having to develop in the Gulf of Mexico, how can that make its way back to Montana and help the industry here?
So a lot of that already does. So one of the perks, besides it being kind of a nerd heaven working in the Gulf of Mexico, is that a lot of the financial constraints that you're under working onshore under tighter budgets aren't as tight when you're spending $1 million a day on a project that's going to cost $250 million for an individual well. So what is seemingly a huge technology or research investment when you're spending 5-digit budgets is not as big a burden when you're spending 7-digit budgets. So that's part of the reason that development is happening where we're happening, as well as from the environment we're dealing with really pushes innovation. I love to hear about the colleges doing the research and things like that, but I firmly believe nothing pushes innovation more than a need. When you have a business need to deliver, it's amazing what gets created. So when you're drilling wells that are 30,000 PSI, which I want you to think about that, how much pressure is in your car tire? And you've seen one of those blow. I'm at 30,000, not 50. And we're talking at temperatures that are 350 degrees, right? So the environment in which we operate demands technology. And really with that, I mean, I'm trying to push a mile of pipe through 4 miles of pipe with roughly 1/8 of an inch clearance. Little things like that really, really do push you. And a couple of examples of things that offshore were pushed that have actually been utilized in our backyard in the Bakken is one of the technologies called wear socks. And what it is a spray-on steel. So where it started was in those tight tolerances where I'm trying to run pieces of pipe casing in that tight tolerance and try to keep it central. You didn't have a mode to put any other mechanical barriers in. So they actually developed a liquid spray-on steel that we put directly to the pipe to be able to mitigate those tolerances. Well, a few years later, when you're drilling extended reach Bakken wells at 10,000 feet, and the abrasiveness of the formation as you're drilling is wearing through drill pipe, putting holes in it, and causing you to have to purchase that over and over again, which nobody wants to spend more money than they need to. Applying this spray-on steel extended the life of the drill pipe significantly. So it was an application that started offshore that found a new home in our backyard. Another example of that is smart completions, which started out in deep water. When you get, in these deep depths and you're underwater, having access to the well is very difficult. So being able to put mechanical barriers in to stimulate and produce from different zones in the reservoir, that is another application that has been widely used in the unconventionals with extended reach plays and able to effectively stimulate and then get the best production over these extended reach wells. So that is just a couple of examples. There's dozens, but it always comes home.
Would you say that most of that information is coming back through business channels, or is any of it making it through the university system?
I would say most of it is business channels, but I do know that as far as when you get individual topics, whether it's you're looking at a packer element component, I know cementing techniques, they really focus, that's where you get a lot of the university support to take the time and really dig in the details of individual pieces. Applications are definitely driven by the business need, so.
Sure, thank you. Shannon, I wanted to ask you, I know in our business we always talk about risk management and things like that, and as part of that, I was curious what percentage of the U.S. electrical generating capacity is powered by coal, and why do you feel it's important to have that as part of the fuel mix for the U.S. power generation?
That's one thing that we always try to highlight, because really, if you look at the electricity generated, I guess the data that we have for a full year going back to 2014, if you look at what the installed capacity of the coal generating fleet was in 2014, that capacity was 29%, but it also generated 39% of our electricity. This is true of some other base load. If you look at nuclear, its installed capacity is only 9%, but it provided 19% of our electricity. And so I bring up that point, and I could go, natural gas, 40% of installed capacity, but yet only 28% of our electricity generated that year. And I think even renewables was less, 18%, and generated 13%. And it's important to recognize that because particularly as we're looking at the threat of all of these shutdowns of that existing capacity and a lot of that baseload generation that's aging out, that's well over 60% of the electricity that's generated in the United States. And if we look at our generation portfolio the same way that we do as our retirement portfolio, and we're right now being driven to build, quite frankly, it's mostly natural gas because renewables doesn't yet have the opportunity to provide the baseload need that we need in this country right now. We're seeing ourselves set up for a situation where we don't have that diversity in our portfolio. And so we look at that from the perspective of again, driving the need for accelerating these technologies, some of these transformational technologies that could be candidates for helping to replace that fleet when it is going to retire, but then also so that way we do have an option in coal in the future in order to diversify that portfolio. I mean, we've learned from experience, if you look at the European situation in Germany, for example, you know, the dependency on renewables results in the Germans having 40 cents per kilowatt hour of electricity cost, or you look at Fukushima and from experience there. And even here in this country, with a lot of natural gas, in the past, we've had historic price volatility. So, and then every resource has its challenges, as I mentioned. So it really lends itself to making sure that we have the technology and the investment in the technologies to make sure that we have options available for all of our fuel sources in the future.
All right, thanks. Carl, Montana's historically been a net energy and resource exporter. How do we maintain this economic position given the changes we see coming in the future?
Well, I think we got to understand who we're selling to and what they want, and then try to figure out how to deliver that. It's no different than if we were selling widgets or anything else. The technology's changing, the market's changing, the interest of our customers on the export side are changing, and we're going to have to try to figure out how to respond to that. I mean, we are lucky if you take the electrical segment itself, we're lucky because we have this incredible wind resource that ends up being cheaper because of its capacity factor than if they were to build that in Washington or Oregon. And so even with the transmission, and now that we have transmission in the ground, if we're going to replace coal electrons with renewables, we have the chance to compete on price and export. And again, not to harp on the Gordon Butte situation, but we're creating something where we can base load that energy in a very robust way. And that's not, I wish I could say I designed this very elegant construction of this plant. I didn't. It's not cold fusion. It's in the ground spinning. It's not anything new, but it is something, because it's not new, that I can get financed. And that's very important for a project of the scale we're talking about. So again, I think it's just, without picking whether it should be coal, gas, wind, and what mixture of all that, I think it's changing. We got to figure out what people want to buy from us and keep trying to export and maintain those jobs and that tax base.
Thanks. Thank you. Curt, you know, we've traditionally been a centralized power type of electrical system. How do you see the advent of distributed power affecting Montana's energy system?
Well, I think a lot of it's going to depend on kind of the adoption rate and how fast distributed generation, if and when it is adopted, and of course at what levels of penetration. I already talked a lot about what we have to do in the distribution infrastructure, you know, to basically be able to handle distributed generation and so forth. But I think mostly what you're going to see is, obviously there's going to be, again, you know, emphasis on distribution management systems. You're going to see, because again, most of this distributed generation is intermittent, you're going to probably see more emphasis and more focus on forms of storage. And storage, you know, in whatever form, could be, you know, a major game changer in terms of adapting to distributed generation. Otherwise, you know, the focus is more heavily changing thermal resources so that they can become regulating resources. The offsetting benefits of distributed generation might be, you know, if it's put in the right place, to offset future capacity upgrades that might be necessary in the grid. There's also some neat technology with smart inverters where it adapts very nicely with some of the things we're trying to do with voltage support, frequency support, and so forth. So there's some advantages to that as well as reliability. So So there's obviously some neat things that distributed resources can do. There's just that from our standpoint, you know, there's a lot of things that need to be done to the grid to make sure that you can adapt to a large scale form of adoption.
Good. I think we got time for a couple more questions, and then we're going to open it up for some general questions from the audience. This one's for Crystal. Crystal, since we already outed you as a Montana Tech grad, what's the importance of providing opportunities and exposure to energy for young Montanans?
Well, I think the importance can be seen if you just look around this room. Where are all our young energy leaders? There are a few. But if we're talking about the future of Montana, we need to give exposure more to those young Montanans that are looking to pursue a future here in energy. As far as exposure goes, I think there's a lot we can do. I mean, when I was graduating high school and trying to figure out what I wanted to be when I grew up, I had an aptitude test tell me I should be an engineer. I thought that was the guy that blew the whistle on the trains at BNSF. So obviously I had to do some educating. So I think there's obviously a lot we need to be doing to not continue to be an exporter of what is arguably our best resource, which is our best and brightest here at home, our hardworking Montanans.
Thank you, Crystal. I agree with that. Shannon, I'm going to give you the last question here before we open it up. What is the state of clean coal technology, and how will it impact how we generate power in the future?
I think that today, clean coal technology really is focused on the need for low carbon generating options. And so if we were to say that we had a technology that could be pulled off the shelf and put onto a coal plant, we have it. As I said earlier, we've not integrated it into a generating system yet, but we need to do that. It's a function of cost at this point and making sure that we can get the kind of operational information that we need from testing that in an integrated fashion. But I think that we also have a lot of ingenuity and innovation taking place in what I call transformational technologies that provide step change improvements to the way that we convert coal to useful energy. There's a lot of opportunities in pressurized oxygen combustion, something called chemical looping, looking at, instead of using steam, using pressurized CO2 as your working fluid. And there's just a lot of options that are out there. There's advancements that are being made in membrane technologies for CO2 capture right now, and there's also a lot that's being done. We heard earlier from the Crow tribe about looking at beneficial use of CO2. Rather than looking at it as a pollutant, we need to be looking at it as a potential commodity and innovating in that space. So there's a lot that's going on. I think part of our challenge is that we suffer, quite frankly, from, when I say we, I'm not really talking about just coal. I've had somebody try to tell me once that maybe we should call it vintage biomass because we tend to suffer from a PR problem, and I think that that's probably right. I think that we need a lot more coming from the business community talking about that there's a lot of innovation that's taking place in this industry, and we need to be investing in it. And we need to be investing in it because you can't get to a low carbon generating future without investing in these technologies. So that's, I think, one of the important things that we need to really be working on as an industry.
Just as a follow-up, are there programs out there that funding programs to help get some of this technology?
There are there's a federal program, there are a lot of federal policy tools that are in place and those that we're trying to improve. We heard Colin Marshall speak about a carbon sequestration credit yesterday. There's a lot of industry and stakeholder action underway to try to get a lot more of that stakeholder input, but again, I think that, and there are state programs and state funding, especially in a lot of the coal states out here out west, so it's a matter of trying to, I think, leverage some of the federal policy tools with state policy tools and trying to get these projects across the finish line, but there are tools available.
All right, thank you, Shannon. And I guess at this point, we'd open it up to any questions from the audience, and I see one here, but we need a microphone.
I can't pass up an opportunity to ask someone from my hometown a question. So this is for Crystal. You grew up on the Rocky Mountain front. You work in the Gulf of Mexico. You know a thing or two about special places. Cobalt's drilled 5 of the 10 deepest wells. You're their senior drilling engineer. You know a thing or two about technology. Public policy seems to be shaped more and more by public outcry and ideology. And my question is, with regard to special places and technology, is whether or not the innovation has come far enough to rebut the claim that some places are just too special to drill or to explore for those untapped resources that you mentioned sooner.
I think the way you phrase that answers that question, that often it's driven by perception rather than reality. So the opinion that people carry is often not based in a lot of data, right? And like you said, I work in a field that I'm very comfortable with and very technical savvy. The average voter, consumer, landowner obviously does not have my depth of comfort in our technology. And that's one of the burdens we have to do, is to educate in order to build that comfort. We're never going to get everybody, but that's our job, is to just demonstrate what we're capable of.
All right, I think we got time for 1 or 2 more. We got anybody else?
So this one's for Crystal. I just wanted to know what kind of technology did the oil industry have since the BP oil spill? I mean, what did you guys learn from that?
So much. Obviously, that is one of the greatest tragedies in our industry. And it's something that I carry with me every day of my job. When that happened, I actually was working offshore as a rotational engineer. And I call home, my grandma was alive at the time, and I'm talking to grandma and mom, and they immediately went to that perception of how bad BP was, those bad people. And I had to remind them that there's an engineer sitting in that BP office whose world has crushed, that has taken a personal view on that as far as mistakes were made. So as far as that, what did we learn? Looking back at that incident, there's numerous failure points. It's one of those terrible traditional cheese wheel where nothing is flawless. There's always holes. And where you have the big incidents is when the holes line up. So there's obviously been additional steps to ensure that some of those holes are forever filled. But it's a constantly evolving. We're an industry that constantly improves. So does that answer kind of tech? So technology-wise, like I said, is constantly. So one of the main things on there was the blowout preventers. So we've obviously made upgrades throughout that as far as additional barriers, higher pressure ratings, additional functions on a standpoint in a failure mode for response. I'm going to jump on the regulation bandwagon. There's been a ton of additional regulation, some of it helpful, some of it not. But yes, so on every front, improvements have been made in response to that incident.
Thanks, Crystal. It looks like we're running out of time. I wanted to thank our panelists for a lot of you are traveling from long distances, so I appreciate your traveling and coming down here, and thank you to Senator Daines for putting this on. Thank you.